Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your red shifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry. Through the Telescope is sponsored by Pic Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So Rose, today we're going to be talking about exoplanets. So first of all, what the heck is an exoplanet?
Well, an exoplanet is a planet around a star other than the Sun.
Right, well, there are lots of stars that are not the Sun. So
Yes.
how many planets, how many exoplanets are there in the universe?
A lot. I guess you are asking how many have we found?
I guess so. But surely people have worked out, like, we've got 8 planets, so just times that by the number of stars we can see, mess around with. There are some stars that don't really have any planets, or, that kind of thing.
So, yeah, that would seem perhaps a sensible thing to do. So we've discovered about 5,200 so far.
Okay.
That have been confirmed.
Okay.
So first off, you can observe an exoplanet, but if you only have one observation, then it's an exoplanet candidate.
Okay.
So you have to have 2 separate observations, like an observation and then a backup observation, to prove that what you have seen is not something else, to confirm that it is an exoplanet. And ideally that would be found in 2 different ways, 2 different methods.
Right, okay, yeah. That's a pretty common sort of science thing of prove something, then somebody else that is completely unrelated to the first study has to work out, that's also true for me.
Yes.
So
the reason that I'm getting at this is because it seems that having, at least from our observations so far, having 8 planets in a system is unusual.
Okay.
So to just say, well, there are however many stars out there, times that by 8, that's how many planets there are, is probably going to be very wrong.
Should we be times it by 5 instead? Is that what you're telling me?
Well, we don't know how many... The truth is we don't know how many planets most stars would have.
Because we don't know what most stars are like.
Yeah, we just don't know enough about other stellar systems or planetary systems, which are both other names for solar systems. We tend to not say, at least scientifically, call anything else a solar system.
Because we're Sol.
Because the only solar system is our one. Everything else is a planetary system or a stellar system.
Is that official? Does the world of astronomy and astronomers, do they call our system Sol, or is that just like video games and movies? And it's like Earth in the Sol system.
Probably a mix. I mean, I think some astronomers would describe it as that, but others not so. Most of us would just call it the Sun and the solar system. Also, I was under the impression that the like a sol is like a measurement of time.
Oh.
Like a day on Mars, a sol.
Oh. It's specifically Mars?
Yeah.
That's weird.
There's one for you to fact check for me.
That sounds like a cheeky Wikipedia.
Well, anyway. So yeah, we just don't know how many planets there are out there, and we don't really know what to expect because we might understandably think that our solar system is normal, but it doesn't so far seem to be.
So these 50... Hang on, how many did you say?
5,200.
Okay.
Roughly.
So are these then just like planets on their own? Have we just found 5,200 planets out there and that's it? Or have we found any where it's like there are 8 or 5 or 3 planets all in one?
Yeah, we definitely
system.
have found multiple systems that have multiple planets in. So from those 5,200, there are that's from a collection of about 3,900 stars.
Okay.
So that would be, 3,900 planetary systems.
So there's a lot where we've only found one.
Yes.
But there are some where we found more than one.
Yeah, like 3, 5, whatever.
But not 8.
I don't know about 8 specifically, but...
I mean, it took us a while to find 8 in our system, so...
Yes.
I guess it's fair dues that it's taken them a while to work it out in other ones, but...
Yes, and as well, often different methods of finding exoplanets are good or bad for different things.
How do you mean?
So, finding a Jupiter-like planet might be good with one method, but bad with another.
Okay.
And finding an Earth-like planet might be good with a different method, and bad with that method that you've used to find Jupiter.
So without knowing anything about this, right, I would assume if somebody was to tell me, go on, find a planet out there, then first of all I'd be looking for alien TV waves, because that's easy, they're sending it to you for free. But apart from that, then I'd be thinking, I'm going to find Jupiter because it's massive. So that must be the easiest one to find. But you're saying that there are some where Jupiter is actually really difficult to find.
Yes. So different things make, planets easier or not to find. And it depends on the method you're using. But in general, a big planet, like in size, is going to be easier. A massive planet, as in, lots of mass, heavy, if you like, that's not scientifically correct, but is going to be easier to find. A planet that's close into a star, kind of like close in like Mercury, not far away like Pluto, in general is going to be easier to find. But, there are all sorts of planets out there. They're not all very big, very massive, and very close to the star.
So I don't know if this might be sort of a slightly philosophical point, but how do you know that you found a planet? I mean, I guess you know that you've not found a rock, but how do you know that you've not found something completely different? Like, I don't know, I guess a moon doesn't really make sense, but like a small sort of failed star or something. Do you know what I mean? Yeah,
it's a big problem, especially with some methods. The radial velocity method, which we'll probably chat about later on, especially suffers from this. That it is difficult to be certain that what you found is a planet and not a star.
Right.
Like a companion star.
Oh, okay. Yeah.
And probably some of the observations of that, whether they're some of the candidates or whatever, are probably not exoplanets. So as well as the 5,200 that we know exist, there's like over 6,000 from TESS, one of the telescopes, the space telescopes, looking for exoplanets that haven't been confirmed yet. They're just exoplanet candidates. There are lots of not yet confirmed exoplanets. And if you are observing through methods like radial velocity, it's quite likely that it might be a star that you found. And the only way you can really determine for certain that it's a planet is, first of all, you have to say, well, it can't be more massive than, I think they say, like 10 Jupiter masses.
Okay.
Otherwise, that's going to be a star. But equally, that's why it's important that you use another method to confirm what you found.
Because if you
another method might say, well, no, that's definitely a star, that's not a planet. You know.
But you can't. It's sort of the case of if you use one method that says there's a planet there, and there's another method that you can't find anything there, that doesn't mean it's not there. It just means that might be a poor method to detect that type of planet. Is that kind of the case?
Yes, I mean, ideally you're going to pick a method that you think will suit the star, the planet that you think is there, or that system.
Yeah.
And that you, as you think it exists.
You're not going to set yourself up for failure.
Yeah.
Basically.
But yeah, just because you don't see something, it doesn't mean it's not there, like you say. But equally, you know, you can get false positives for all sorts of reasons. So yeah, that's why it's important to confirm that it is in fact an exoplanet and get more than one observation.
So we've got stars that have one confirmed exoplanet. And we've got stars that have more planets. Does every star have a planet? Is every star somewhat like our system, or even like a less good system with only like one planet?
There are different generations of stars in the universe. The first generation are like the first ever stars.
Okay.
That ever existed.
The first generated stars.
Yeah, exactly. The first stars in the universe. So they're made only of hydrogen and helium.
Mm-hmm.
And then the next generation, after these stars have gone through their life cycle, would contain, you know, a small percentage of other things from hydrogen and helium.
Right.
So the star makes, you know, the star burns through its hydrogen and helium, and it makes other things. It makes other chemical elements.
Yeah. And so star number 2, generation 2, is made of the sort of dead corpse of the first star.
Exactly. So it's got hydrogen, helium, some lithium, bit of beryllium.
Yeah.
All, you know.
I know the chemical.
Exactly. I don't need to tell you as a chemist. All the way up. Not all the way up, but, you know, a whole range of different things. And astronomers, much to my dislike and emotional upset, call everything that's not hydrogen or helium metals.
Right, well, they've got that wrong.
Yes, they have. But
was there a reason why?
I don't know.
Like, did they...
There maybe was a historical reason. If any of our listeners know what that is, maybe they could let us know. I still won't accept the word metal.
Jeez.
Because it upsets me greatly and it's just factually incorrect.
Metal.
But we're going to go with it here in this explanation anyway. So generation 2 stars have a small percentage of metals in them.
Right, so they've got a little bit of heavier elements that are not hydrogen or helium.
Yeah. And then the next generation will be the third generation. And that's where we're at now.
Okay.
That's stars like the sun.
Presumably at this point we're burning through more and more hydrogen and helium, and we're making more and more of the heavier metals.
Exactly. So they have a higher percentage of metals, inverted commas. The generation 3 stars,
which is us,
right, with the higher percentage of metals, are population 1 stars.
Wait, sorry, what?
That's another name for them.
Wait,
or the proper name for them. Population 1.
What?
Because we look around in the universe, we see a lot, I guess, of... We knew about them first.
Right, so we're generation 3,
Mm-hmm.
but we're population 1.
Yeah.
Oh.
Yep. I know.
Okay.
Generation 2 is population 2.
Well, that's handy.
Yeah. But also confusing. Because if you think about them, you're going to get the other ones confused.
Generation 1 is population 3?
Yes.
Okay, so it's like UK and US knitting needle sizes.
Yes.
Which go up and down.
In opposite directions.
In opposite directions.
Yes.
So, is it the UK, smaller needles have a larger number, and the US, smaller needles have a smaller number? Something like that. Or you could just use the metric diameter of said knitting needles.
Right, yes. I'm sure that is true. But that's not helpful to our understanding here. So.
Jeez. So we've got population 1 star and a generation 3 star. And that's the
Yes.
same star.
So, yeah, we haven't actually seen or found any population 3 stars. The generation 1 stars.
Right.
Because they would be so old. We know that they must exist. Because there must have been first stars.
But I guess by definition. Unless they were always there. Were they always
I
there?
suppose that's true, but... Anyway, to make planets, you need metals, inverted commas.
Right.
You need something that's not hydrogen and helium.
Okay, yeah.
So,
Yeah.
back however long ago, when you asked how many stars have planets, if you consider all stars ever, then the answer is then not every star has a planet. Because the first stars shouldn't have had any.
Yes, because there's nothing to make the planets out of.
Yes.
Yeah. But can't you just have like a small sort of... Isn't Jupiter like hydrogen, helium?
Yeah, mostly. It does have some other stuff in though.
So could you not just have like a little ball of hydrogen and helium left over that's not collapsed into the star?
Maybe. I'm not sure, and I'm not sure if... I'm not sure what it would form into. Possibly.
It's a mini star. But if it doesn't combust, is it a planet? Combust. Fuse. Is that the right word?
Well, brown dwarfs
Hmm.
are not capable of sustaining their own nuclear fusion.
Okay.
But they're not planets.
Are they stars?
Yes.
What's the definition of a star?
I don't know, off the top of my head.
And is it a definition which happens to include brown dwarfs because people
Either
have previously said brown dwarfs are a star?
either it will have adapted to fit brown dwarfs, or brown dwarfs will be in that awkward not anything
Right.
own category, if you know what I mean.
Yeah.
I don't know, off the top of my head. But they're not planets.
So going back to the generation thing,
Yes.
is there a generation 4?
Well, there might be.
And is that a population 4?
Well, I don't think there is right now, because I'm not sure what the difference really is. I'm not sure if there's like a cut-off to do with the metallicity
Okay.
or what. I'm not really sure why the populations were defined the way that they were.
Might need to get some kind of like star formation person to tell us, because this just sounds like a lot of science. It sounds like people started classifying things, but they didn't have all the things available to them.
Yeah,
So
that's
they
how a
didn't-
lot of things in astro work.
They didn't really work it out properly, whereas if they just waited another 50 years or something, we would have known about everything.
Yeah, another good example of that, speaking of stars, is like the classification of stars. You know, like O, B... Like the different types of stars, like O stars, B stars, G stars, M stars.
M stars.
Yeah, M dwarfs.
Oh, you worked on M dwarfs.
Yeah.
See,
well,
I
those
take an
different
interest in your
types of
research.
stars were like, this classification was invented, and then you like learn a little acronym
Right.
for like all the different types of stars.
Okay.
And then actually there's like however many more.
Right.
Because, like you say, science catches up with itself.
I mean,
You
you've
classify
already...
things.
You
and
started
then-
off by saying what did you say? OB,
Yeah.
which is already was not AB.
I don't know. A is smaller than B.
Yeah. O is a lot bigger than B.
Mm-hmm.
Assuming we're talking about alphabet and assigning numerical values. I suppose just writing really big O's.
No, I was talking about the mass of
Oh,
stars.
so it works, does it?
So, from big to small,
Mm.
O, B, A, G.
Okay, hang on.
No, it's not G. It's too late. Oh, be a fine guy, kiss me. Point is, that seems like kind of nonsense. And then it turns out that there's also, like after that, it goes like K, L.
Jeez.
And then they can't do M because they've already done M.
Right. Why did they even come from all these? Gee.
Yeah.
It's like in chemistry, the SPDF. I can't remember which one they found first, but D is like diffuse. S is spherical, and P
Yeah.
I think is primary, based on something that I should remember, but I can't remember. So you go SPDF, and then they get into a groove, and they go GHIJ. Like now it makes sense,
Yeah.
apart from when we come across letters that we've already done. So.
And then you got to skip them because we've already used them. Yeah.
Yeah, but luckily, I don't think we ever really get that high of F. So some people probably do, but yeah, I love a made-up system that doesn't quite work.
I think, for me, I kind of feel like stars should have a planet because when you think about how a star is formed, maybe we'll talk about this in more detail in a future episode, but it feels kind of natural, if you like, for there to be bits left over that would form into a planet.
Like a IKEA flat pack set where you always have like
There's always a leftover screw.
Yeah. And you're like, should this be attached to something?
Yeah. Should I really sit on this sofa?
Yeah.
Or not? Yes. Yeah, but again, I think like they're all questions that seem on the surface quite basic. Because they seem basic, that makes us feel like they should be simple to answer.
Mm-hmm.
But our understanding of the universe is not that great. We don't completely understand how planets form. We understand somewhat how planets form, but there's still a lot of debate about how our solar system came to be how it is, and how the planets in it came to be how they are. So we obviously don't know that much about planet formation.
Okay, we might need to have an episode on planet formation because I feel like there's quite a lot I want to ask you about that. I wonder if it's just kind of, the sort of, what's the word? I guess kind of parochial kind of viewpoint. I don't really know, but until you experience something different, everything that you can imagine is sort of very similar to your lived experience, and that's also true with sort of with the solar system and other stars as well. So you kind of have, every star must be kind of like the sun, and every star must have planets like we have planets, and maybe lots of them will have an Earth-like planet with life, for instance.
Yes. Yeah.
I guess that comes down to what's that equation? With
The Drake equation.
probably.
About how many planets have
How many
Of
aliens
life.
are out there?
Yeah.
And how quickly they will have destroyed themselves.
Going back to your original question of how many exoplanets are there, it's also, as with all things in science, maybe not that straightforward, because you can find, if you go onto Google and you search that question, you'll find a few different answers.
Yeah.
You won't find just the answer that I have given to you when I went to find the latest up-to-date, as of 1st of January 2023, how many exoplanets are there.
So people
you
listening
won't
to
just-
this, there could be more.
Yeah, but even if they went to search today,
Right.
they could come up with a different answer to me.
When you say today, day of recording or day of listening?
The day of recording. And the point is that different databases have different entry requirements for if something is or isn't an exoplanet.
Right. So it's not even, let alone like two different methods. It's different people have different expectations.
So
there's not just one database. There's not just one.
There isn't, but the main one would be the NASA Exoplanet Archive.
Because NASA is the main thing for everything, is it?
They like to think so.
They've been to the moon, Ro.
Yes. Anyway, they have a policy of including and classifying all objects as planetary if they meet the following criteria. And here's a quotation so that we're not plagiarizing them. So we're not plagiarizing them.
I don't know. This sounds like we are plagiarizing them. Because we're putting a quote in, so it's not plagiarism.
Yes.
I thought you meant it's not plagiarism. This is lifted directly from their website or whatever.
Yes. Well, it is because
yes.
it's a quote. But anyway, the mass or minimum mass of your planet is equal to or less than 30 Jupiter masses.
First of all, how can I have a minimum mass? Minimum mass?
So your observations might not provide an exact value for a mass.
Right, okay.
They might provide a minimum value.
Not a maximum?
Not a maximum always, or sometimes that's not of interest.
Okay.
The planet is not free floating, so we'll come back to that again
Okay.
later. But that's a rogue planet.
Ooh.
Sufficient follow-up observations and validation have been undertaken to deem the possibility of the object being a false positive as unlikely.
They need to reword that one, Ro. That one's... So let me have a look at that one. Sufficient follow-up observations. Right, so they're pretty darn sure that it's all right.
Yeah.
Okay.
The above information, along with further orbital and/or physical properties, are available in peer-reviewed publications. So you can't just say, I spotted this,
Right.
and put it on your blog.
Right.
You have to write a paper, a scientific paper that contains enough information about the planet and the observations, and it has to be peer-reviewed by another scientist
Right.
in that field. These results must be peer-reviewed and accepted for publication in the astrophysical literature. I don't really know how that's much different to the other one. Is that like, don't put it in like, I don't know, The Lancet or something?
Right, yeah.
I mean, I'm not sure why
British
you would.
Medical Journal. Just random exoplanet paper.
But yeah, I'm not really sure how that one's different, apart from that. But
Does what about like Nature or Science? Do they count?
probably because NASA Exoplanet Archive probably deem them to be,
Astrophysical literature.
high value enough for them to take that one. Anyway, so
Interesting.
yeah. So basically there are a few different archives.
So there's a
You'll get
paper
different answers.
for every one of these exoplanets, or I guess you might have like 3, But
Yeah,
come
you
on,
might have a paper that's got multiple observations.
that seems kind of crazy when, I guess it isn't really in a way, but when there's 5,200 confirmed ones, then that's a lot of papers. I don't know, I guess it seems like you're at the point where, if somebody was to say, I found the 9th planet in the solar system, I would expect there to be a paper.
Yeah.
When you get into
I'll
the
be
thousands...
honest, I would expect it to be more than one paper.
Right, because you might have...
Yeah, I would expect a part 1, part 2.
Right, yeah. I mean, to be honest, like the stuff I work in with like materials, you got like, I don't even know how many thousands, lots and lots of different materials, and there's a paper published for like each one of them, so it's not really that surprising. But yeah, geez.
I think because when you're presented with the information like that, me sat here saying there's 5,200 planets, it's like, wow, that's a lot of work. That's a lot of science. That's like, especially when you're a researcher and you've been on the end of what it takes to write a paper. That's a lot of work,
Yeah.
But that's not happened overnight. This has been going on for not all that long. Exoplanets is a relatively new field in astronomy, but not like no amount of time,
And it's not one person.
Yeah, it's been going on for decades, and it's not one person, like you say.
So is there like a database of unconfirmed ones that then people will go and they'll check out, oh yeah, entry 1746. I'm going to try and look at that in a different method.
Yeah, I mean, I don't know what it would be off the top of my head, but, things like tests, typically they make their data publicly available.
Right, okay.
So you would be able to get your hands on it and do whatever you want with it. In some cases, they don't. Some things will put like their raw data out there straight away. Other things, it won't go up immediately. Like, it'll be publicly available, but they'll filter it or, process it in some way beforehand.
Get rid of noise or something.
Yeah. I would quite like to do some stuff in exoplanets. Don't tell my supervisor.
Like that.
She just...
Not a fan.
No. I think quite a lot of her students have eventually, once they've progressed with their career, dabbled in the dark side. And I think she gets bored of hearing about it because her husband works in exoplanets.
Fair.
And she thinks stars are more interesting. Which, I don't know. I think they're both very interesting. I mean, I work in stellar physics, so I'm not, like, slagging off stars.
Well, you'd hope not. Although nothing can put you off a subject like studying it, I guess. So, I guess I kind of thought when you talk about it's unconfirmed, it's confirmed, we've now got two different methods. Either you have a database where you just like, I think I found a thing, and you basically like, you put it onto Facebook or wherever and you say, does anybody know if they've got like a different telescope or something to check out whether this is correct? Yeah, so that's option number one, sort of like a community notice or public database of unconfirmed things. Or you hoard the information and instead you go to either your other telescope or you go to your friend who you've published lots of papers with, who has a different telescope, and you say, don't tell anyone, but I think I found an exoplanet. Do you want to join in?
Right.
And then they go, boom, confirmed exoplanet out of nowhere.
Yeah. I mean, you could do that, I suppose. I think that probably in most cases, there is a lot of collaboration that goes on in astro, as with many science things. But I think, you would maybe, if for whatever reason you really wanted to keep your hands on this particular exoplanet, you would maybe hold back on publishing your paper on that, but you would still write your paper about it being, this exoplanet that you found, and then, either give your collaborators a head start or just wait for whatever reason. I'm not sure why you would want to, but maybe, for some reason you do. Wait for them to write their follow-up paper confirming it. You wouldn't make that one paper.
Some of it's like the politics of research and the process of publishing and sort of prestige, etc., etc. You know what I mean?
Yeah, I mean, again, maybe this is something for a strange, different podcast episode. Publishing in science takes a lot longer than the general public think it does. You don't make a discovery and then that's your eureka and everyone knows about it.
Yeah.
It takes a really long time to go from research idea or strange observation or whatever to published paper, especially if you're trying to get a peer-reviewed one, which in most cases you are, because that's how science better operates. So, yeah, like you say, there's a lot of politics that goes on, and it's maybe not the kind of politics that people would expect. There are some rivalries and things, of course, but I don't think that's the kind of politics that normally influences people's decisions about these things, is that it's more trying to make sure that they can have a career.
Yeah.
Because it's a very unstable job and career in academia.
Part of that is gambling on whether you can get more information yourself, or get more analysis, get more out of the data yourself, or whether somebody else will have published something on the thing that you're doing to a greater or lesser extent sooner.
Yes.
And then even if your paper would be like far better than what has just been published,
the
novelty has been lost.
Yeah.
And I guess that's particularly true when you're discovering something like an item, a cosmic item, for the first time. So are there any particularly interesting ones out there?
Yeah, lots of weird exoplanets. So here's a few that you might be interested in. Let's do them briefly.
Okay, so there's 5,200 in total, are there?
Yeah.
So this is a selection.
55 Cancri E. A diamond planet. Maybe.
Nice.
It's a carbon planet anyway, and it's been superheated.
Okay.
So therefore it might be full of diamonds.
But it could be graphene. Or graphite, rather.
Yeah, I mean, I haven't read the paper, so I don't know, like, would they give different light signatures or something? Presumably.
Presumably. Very different bonding.
But yeah. Yeah, the linking between chemistry and astro here. HD 189773b.
Was that HD 189773b?
Yeah.
It just trips off the tongue.
It does. It rains glass sideways there, maybe. So at least it has silica in the atmosphere.
Okay.
That's heated, and it makes glass.
Okay.
And then it falls back towards the planet. And it's also mega windy.
Right.
Because it's got two very different temperatures on different sides of the planet. So, yeah, maybe like glass tornadoes or glass winds anyway. Sounds awful and very painful. Pretty weird though.
That is, yeah.
Or
like proper hailstones, but the stones are made of stone. other amorphous?
Or TOI 849b.
Mm.
It's the exposed remnant core of a gas giant that's had its atmosphere blasted away. It's 40 times as massive as Earth.
So is this like what might be inside Jupiter or Saturn? Is that kind of what we're talking about?
Yeah.
Ah, that's pretty cool.
Yeah.
And
Pretty
is
cool.
this like a gas giant that's got too close to the star or something? Why is it being blown away?
Yeah, if it's had its atmosphere blasted away, then it's likely, that that's been caused by the star.
Because that must be a lot of atmosphere to get.
Yeah, so stellar winds can be pretty damaging.
Jeez.
The material from the star blowing out into space and taking all the things with it, like atmospheres of planets. Also, like, stellar activity in general, like flares or whatever, can also do that. Or you could have like some sort of stellar event, like the red giant blasting off its shell, just leaving the core behind when a star goes through later parts of life. And maybe that explosion is the wrong word, but
Yeah.
could remove that atmosphere as well, or instead. So yeah, there are various different ways. If it's like only the exposed core with nothing else left, definitely suggests, doesn't it, something very extreme.
Very extreme.
So yeah.
Possibly even like Star Wars, like a sort of Alderaan based event.
Tres 2b.
Or not. Tres to be.
The Goth planet, the darkest known exoplanet, reflects less than 1% of any light that hits it.
So if it doesn't reflect any,
Yeah.
or near enough, then it absorbs all of it. Does that mean it's hot?
Yeah, probably.
Or does that just mean that it's quite far away from everything, so it's hotter than you might expect it to be, but it's not really hot?
Well, it's specific. I guess if it was really far away, then it might not be absorbing much. But yeah, if it's that black, it's definitely absorbing the light that hits it, and all of it is not reflecting it. So, yeah. Basically, what it comes down to is that chemistry on other planets is very different to the chemistry that we're used to. It's not necessarily the same. Like, there's a whole bunch of things that could happen, And so you get very different exoplanets.
And this all comes back into enhancing people's understanding of how planets are formed in the first place.
Yeah.
Kind of. Got you. God, that does actually seem like a reason why we should care about exoplanets. Apart from just they're cool.
Yeah, there's a whole realm of science, of chemistry, physics, even potentially biology that is out there waiting for us to understand it, And it's quite different from anything that we know.
So earlier you mentioned in passing about rogue planets.
Yes.
We've not mentioned them so far. So
no.
What is a rogue planet?
We should just have a brief chat about them, I suppose, since I brought them up earlier. So a rogue planet is a planet that's wandering about without a star.
Right.
And naturally that brings up some questions that I can't necessarily answer for you. Like, was it formed like that? Did it somehow form in a way that it didn't have a star in some way? Or was it like flung out from a system? Which, might maybe seem like a more likely thing. But then how was it flung out from a system? What happened that managed to fling an entire planet out of a solar system or a stellar system? And then, did that happen very early on during the planet formation? Again, back to planet formation. Or did that happen after some crazy event, you know, when the stellar system was very established? Did something, you know, crazy happen? Did another star pass very close by or something?
Yeah.
That disrupted the gravity and flung out a planet, or maybe more than one planet. And then, you know, that's just crazy, isn't it? What would life, what would it be like to be on a rogue planet? You would have no star.
It reminds me of an old American TV show, Space 1999, where there's a moon base on the moon, because where else would you have a moon base? And they've got like some sort of like radioactive waste dump on there or something, and it explodes and it knocks the moon out of Earth's orbit, and the moon gets shot into deep space.
That sounds great for Earth. I'm sure we would have no problems at all with that.
So the TV show follows these people on the moon base as they like have their journey through space, and it's also like they can't stop at any point. They just like encounter new things, and it's like, well, the moon's going this way, so we gotta get back to the moon and keep on going. But I always did think like, but the people at home on the Earth, they don't have tides now.
They have so many problems.
They have a lot of problems going on. But yeah, it basically that, because they just got flung out into deep space.
Also, you can't fling out the moon without the Earth also having a bit of a ricochet going on.
I saw a news article a while ago about a rogue planet, actually. It wasn't a particular one, it was just the concept of a rogue planet. And they were saying that basically, previously, they thought that because planets without a star would be cold because there's no star, then that's it. You could never have any life, because all astronomy subjects always have to come back to, is there life? And then some smart people did some calculations, and they thought, actually, if you work out the energy from the radioactive material that may be present in a planet, then actually, if there was a thick enough atmosphere, then the planet could be warm enough to sort of sustain life, as we vaguely know it. I guess have liquid water, etc., even though there's no star nearby. Which, when I read it, I was then thinking, gosh, can you imagine if there were, like, if it lasted long enough, then you could have like an entire civilization sort of grow. And I mean, I don't know what kind of life forms would come about when there's no light in the sky, especially if the atmosphere is so thick you can't even see the stars. But, you know, you could end up growing up on this planet and maybe even working out that the planet isn't going to be around forever. You gotta get yourself out of there at some point and go off, find a star, or maybe try and angle your planet towards a star. But I think I was just going a bit crazy at that point.
Yeah, but then maybe you don't need to, because maybe the amount of time you've got is so long.
And you're like, well,
you know, should we start looking for a new planet? Because when the sun starts to become a red giant, it's going to swell and get very close to us.
Well, Elon thinks so, but I don't know that Mars is going to,
you know,
necessarily be a final destination in that case.
It's going to be so long away.
Yeah.
That there's no reason to believe we need to leave for that reason.
Yeah.
You know? So maybe you wouldn't. Maybe it would be the same thing. And with that really interesting and strange thought, I think we should leave it there.
Yeah. So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and if you like, you can leave us a nice positive review as well. It really helps the show, and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.